So you have yourself some sort of black box radio. Now in the case of this one, it is a RCI 2990. Now this is going to hold true for basically any of the RCIs, actually any of the export radios this style. So mobiles and base stations that have, as the little pad falls off, built-in frequency counter with a CPU-controlled module behind here. This also holds true for radios like the President Lincoln, the original, not the new versions, but the original from back in the 90s. Also the HR 2510s, 2560s. Those style radios they don't use a channel selector switch, they use a rotary encoder. They're known for going bad. Now, they're old for starters, God knows how many, probably thousands, tens of thousands, if not hundreds of thousands of times those things have been turned. So, parts wear out. Now, Ranger does make a replacement for these. Actually, have some of them. Get out a little pack here so you can see it. Comes in a little kit. Get out of there, wire. So it comes with a new wiring harness, a new rotary encoder, but you can see much smaller, tiny little thing. The updated harness, because this uses a different plug than the original harness, so it includes a new little jumper harness to get over to the CPU board, and includes the nut, the washer, and then also the mounting size here is smaller on this new one than on the original. Okay, you see the shaft, the threaded diameter there is a lot bigger. So, this thing would wobble around in the hole. So they also include this little bushing, stamped out bushing adapter, which slides on here, like so, and takes up the slop. So you can see they have it belled out right there. They did that with a dimple die. And that keeps it from wobbling around in a hole and keeps it centered in a hole. Now, you can either buy one of these. You can get these from basically anybody that sells Ranger Galaxy parts. So like R&R Communications, or just name the company that sells parts to repair Rangers and Galaxies. They'll be able to get those for you. Only problem with those is they don't have the same feel, rotating force and whatnot, and clickiness as the originals. That's one thing I kind of like about these. These were made by Accord, where the new one is an Alps control. The originals, as you can see, you get reflection right, you can see Accord, okay? So it's basically what Accord did was, they took one of their normal channel selectors. Difference between a channel selector and an encoder is, you can see an encoder has these little windows, okay? So it pulses, basically. Okay, when you turn the dial in one direction, one of these fingers here, okay, is going to make contact, because you can see they're offset slightly. Get in close enough. You can see how those lines, it went out of focus. Let me get a pointy thing so I'm not putting my finger in there. Getting it out of focus. Just doesn't want to focus on that little disc. Yoop. Focus. Okay. You see how those lines aren't perfectly straight? So when you turn this thing, one of these is going to make contact with one of those little wiper fingers before it makes contact with the other. And that's how it knows what direction you're turning. It can tell by, if it gets contact on this finger before it gets contact on this finger, it knows you're turning clockwise, or vice versa, you're turning counterclockwise. Now, I'm going to rebuild the one in this radio, and I want to show how to do that, because it's a very simple process. You do need a few little tools, but nothing fancy. So, first thing, you could use a razor knife. I just use a pair of diagonal cutters. So, first thing you do, unsolder the encoder off of the circuit board. Of course, I didn't think about this till after I had it apart, but I did remember to do a video on it this time. But remove it from the board, so desolder the 5 pads right there, pull it off. Now you're going to find this put together, come on, get in there little guy, just like that, okay, with the little plate on the back. Now what's holding this together is plastic, okay, so there's 4 little dots of plastic. That's what I actually cut off. down there. There's 4 little specks. Okay, so originally these little plastic fingers, or pieces that protrude out there, actually stuck out. Before this thing was manufactured, they stuck out a lot farther. And then they heat them up and basically melt them and smush them down to sandwich it together. And that's what holds it together. Those little pieces of plastic that were melted over. So all you need to do is come in with a pair of wire cutters. Like I said, you can use a razor knife. Just be careful you don't slice your finger off. But I just use, because these are flat bottom, I just come in and snip all four of those little pieces of plastic that stick out the back. Pull the back plate off. Pull the rear section off. Now what I do is, usually you really don't have to clean this because this is gold plated, but I got it apart. I'm just better safe than sorry. So I take my little fiberglass brush, I just really quick just run around here, give it a good polish job, and then I'll clean that off with isopropyl alcohol and a foam swab to make sure that's very clean. The main thing that's causing the problem is, and it's not oxidation actually, but it's, again, while you're in here, just take care. Now, these are not gold plated, so what you want to do is I just take my fiberglass brush again, because if you see how dark it is down here, close to the bases, okay, that's how dark the entire things were before I took my little fiberglass brush. Again, just gently go over the little contact fingers there. Actually, I don't even have to worry about these two, they're not used. But just clean the little contact fingers off. And that's basically it. Clean that. Now, what's causing the problem is, because the problem you'll have with these things is you'll turn the channel. So you're on 27.205, let's say. You turn the knob one click to the right, and all of a sudden you're on 27.255. So you've jumped 50 kilohertz. 5 channels. It's like, what the heck's going on here? You turn the knob back the other way, and now you're down to 27.185. Or it'll turn halfway fine in one direction, and you can just never seem to get on the frequency you actually want to get to because it's skipping. And the reason that happens is you're getting what they call bounce on these contacts. So even though very small contactor, it's a CPU running this thing, and it's running at a very high speed, so it doesn't take much. A couple little bounces of these contacts as you're going past is going to, the CPU is going to think that you've turned the channel selector knob numerous times, or multiple positions. What's causing that is these fingers. It's not so much that they're dirty, it's that they've just, over the years, and in the case of most of these radios, decades, they've started to lose the spring tension on those fingers. So all you have to do is, once you get them cleaned up, the problem is basically they're pushed down too far. Okay, they've lost their spring, so they're not pushing against this little tone ring here, okay, with the 2 little sets of fingers, or whatever you want to call them, spokes on a wheel. There's not enough pressure. So all you need to do is, once you get them cleaned up, just come in here with something underneath of them. Now, don't go grabbing your, channel locks and grabbing these things and snapping them off. But you can see how much I got that bent up there. And you can see how much they are originally. They just barely stick out. If I get that lined up where you can just see straight across there, you can see you really can't barely see the tips of those. And that's the problem. They're barely touching that ring, and the CPU interprets, because it'll skip as it goes. Even though those traces are tiny, in between here, those little traces in here, they're tiny. That's still, like I say, CPU running very high speeds. It can interpret, 5, 6, 7, 8, 9, 10 steps if that little contact as it bounces across the rough texture of that thing. And that's all that causes it. It's lost its spring tension. So like I say, just bend those fingers so they're sticking up a little bit. That's all you need to do. Now, I will, in addition to that, just to prevent any oxidation, you don't really have to worry about it on the tone ring, because like I say, that is gold-plated, so that will not oxidize. The fingers do. But I still add a little bit of shield deoxit. Now, I use the S100 in the little fingernail polish bottle. It's just all shield. There's no solvent in that. I'm not using it so much to prevent corrosion. I'm mainly using that as a lubricant, because we know we're having problems. You can't get this style encoder anymore from a cord. So, we want to try to prolong its life, basically indefinitely if possible. It's never going to happen, but you want to increase the life of this thing, because eventually all rotary encoders are going to fail. Either the fingers are going to wear out, the actual little contact, the little bump on there that actually makes contact, or it's going to actually wear through these little traces here. And if once it wears through those traces or the fingers wear out, then there's just no fixing it. It's going to be, that's all she wrote. So by putting a little bit of shield deoxide on there, that acts as a lubricant. So it'll help to prevent wear on these components. Then all you have to do is put the back on it, put the rear plate on. Now you're thinking to yourself, yeah, Mike, but you just sheared off all the little plastic ears. Now, it's fairly simple, and I'll pause the video and I'll show once I get this put back together what I do. I just take a pin drill, little handheld pin drill, and I drill 4 tiny little holes in the centers of the plastic that's still there, because it still sits flush with the outside edge here, okay? You can see how far it sticks out. It's flush with the back of the sheet metal. I'll just drill a tiny little hole in the center of those, and then I'll take little tiny screws. So I get these little kits that have little, basically almost microscopic screws. But I'll just use 4 of those tiny little screws to then screw down into those 4 little holes that I drill, and then it'll be sandwiched back together. It's going to hold it probably even better than original, because it's actually, it's a metal screw now on there. Advantage is, in the future, another 20 years from now, when the fingers lose their tension again, which is going to happen eventually. It's going to happen to basically all rotary encoders eventually. But like I say, the advantage of these is they can be taken apart, but the next time, you don't need wire cutters, you don't have to worry about drilling holes. It's already done. Just get out your little screwdriver, take those 4 screws out, pull it apart, bend the fingers up, put it back together. Good for another 2 decades or so. So let me pause the video here. Like I say, I'll get this the rest of these little fingers bent up, put a little bit of deoxide shield on there, and then I'll show you about, like I say, about drilling little holes in there and putting screws in there, and that'll fix it up. Like I say, I've done this numerous times. It works fine. It's a little bit time consuming, but like I say, if you want to try to maintain that nice clunky feel, these are a lot better than the rotary encoders that Ranger's providing now. You can just see the new ones, just how much smaller it was than this one. And they just don't have a lot of what they call rotating force. So, these simulate a channel selector switch a lot more. A little bit clunky, Where the other one, yeah, you can pretty much just spin that thing with one finger. And that's kind of why I don't like them. It's easy to overshoot when you're changing channels, where this one has nice, very distinctive click, 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 click. It locks in. So let me get to the point where I'm drilling holes, and I'll be back. Okay, so I've already got one screw in. You see, tiny little screw, and you can pick these screw assortments up like on eBay. I'm sure Amazon, lots of online suppliers have them. They don't cost much. They're from China, of course. But yeah, it's a nice assortment of tiny little screws, and occasionally you need a tiny little screw. In this case, you need 4 tiny little screws. Now, you can do all of your drilling with a pin vise. That's just going to take you a while, because this is nylon and it's kind of hard. So you're going to be sitting here going like this for a long time with a hand pin vise. But it works. See? Nothing wrong with using that. And if you're working on your own radio, it's just a little bit of time. But what I do personally is I'll use a pin. I still do use a pin vise, and I use it to start the hole with a slightly smaller drill bit than I'm actually going to use to drill the hole. What I'm doing that for is basically I want to make a center, kind of like you're using a center punch on sheet metal. I don't want to come in with the basically electric drill. I'm actually using a Dremel tool with a flex shaft, because the drill bits are too small to fit actually in a normal drill. Even a 3/8 drill chuck won't hold these drill bits because they're smaller than a 1/16 of an inch. They're numbered size drill bits. But I'll use a pin vise with a slightly smaller drill bit than I'm actually going to use to drill the hole to make a center. So I can get in here with this, which is what I was just doing. See, there's a few shavings there. And I'll get a couple rotations, but I'll get a little hole started. I'll never get it to focus on that probably. But that gets a hole started. And then I can reach up here, turn the drill on, and I'm going to try and get this around the camera mount. I can come in with the slightly larger drill bit. I'm going to try and get this. I'm going to have to do this slightly out of camera view, I think, because I got to get in here to see what the heck I'm doing. and make sure we got her straight, and then just push. The drill off, or actually Dremel tool. Get one of my little screws ready. Again, this is another reason fingernails are handy. Always ask me about my claws, and I always tell people my claws are my fingernails. They're not fingernails, they're tools. I don't know how people work without fingernails. And then being that it's plastic, and you've slightly undersized the hole smaller than the screw itself, the screw can then bite into the plastic and tighten it down, and there you go. So 2 more holes to drill. This will be back together. Put it back in the, resolder it down to the little circuit board here, because it'll look just like that when you pull it out, and it'll be done. And like I say, what I use is the Deoxit Shield, the S100. I actually get this in the bigger glass bottle and then refill it. I use so much of this stuff, I actually go through like 2 or 3 fingernail polish bottles of this stuff a year. So I get it in a big glass bottle, which is really expensive, but it's a lot cheaper than buying these, and I just refill this. But like I said, I put that in there mainly more as a lubricant than as a, tarnish or, corrosion preventer. I'm mainly worried about trying to protect those fingers and the little traces in there from actually wearing out. So anything I can do to reduce friction, all the better. I also put a tiny little bit of it where this shaft comes out through this metal plate, because that actually acts as a bearing for this shaft. So, that's actually the bearing, the rear support for this shaft that keeps it from wobbling. So you can see actually there's a little bit of oil residue there right now, and that's from me putting some of this on there. Like I say, again, just a little bit of lubricant to extend the life of this thing. So basically, in a nutshell, that's it. Take it apart, clean the fingers, bend the fingers out, because that's the actual fault. The fingers lose their spring over the decades. Bend the fingers back out, put it back together, drill out 4 tiny little holes, put a few screws in there, put her back together, and you'll be good to go. And, this works. I've done this numerous times and absolutely have never had one come back failed since. They work, perfectly fine. Actually, I've got a few Uniden mobile radios that I've done this, to my own radios to fix the original rotary encoders. Like I say, I want to keep that original feel. I just don't like those new ones. So there you go. Hope that little tip helped somebody out.